Hi folks, welcome to the third video in the Tetris in Erlang series that I'm doing. In the last video, we got as far as implementing the basic game mechanics. We can move around the board. We don't jump out of bounds and crash based on that and so on. In this video, if we look at the commit log, we've gone from a Hello World GUI thing to being able to show a text representation of what the game board looks like, to being able to graphically draw the board with sprites with a random piece on it. And that's where we got in the first video. The second one, this last video I did, we implemented Unsafe Movement, which I skipped over by mistake, and I need to backtrack and actually talk about that, because that's the point at which we start making decisions based on user input. So that's a really, really important thing for any GUI program, especially a game. So I apologize for not having covered that, but we'll go over that real quick here at the beginning of this one. Anyway, we went through, these were work in progress commits. By the end of that, we had movement, line completion, and board clearing. So we could clear lines. We have no game tick. There's no timer in the game. There's no levels in the game. The scoring is not really a thing yet. But we are able to move around the board, make sure that we don't jump off of it by mistake or crash based on that. If we hit the bottom, we will lock into the board and get a new piece. If we hit another block as we're descending, we'll lock into the board and get a new piece. And if we complete lines, they clear correctly. So that's how far we got last time. Backtracking to this unsafe movement thing, which I forgot to talk about. Let's... I'm in too much of a hurry. If we run this, what we'll see is if I press spacebar, I get a piece. I can flip it around either way, and if I try to go off the side, the thing crashes. The reason for that is if we look at the do move function, there is no boundary checking here at all. We're just moving right by incrementing x, moving left by decrementing x, and moving down by incrementing y. Because remember, the coordinate system starts at 1, and the highest value is the bottom of the well, not the top. So the important thing about this particular commit is how we handle, how we get input from the keyboard, and then how we make a decision based on it. It's the most important thing to understand about this commit. So the first thing to note here is the wxErlang library provides for us an extension of GenServer called wxObject, and that's this guy right here. So this is very, very similar to a GenServer. If you look at the callbacks, you'll recognize them all. Handle call, handle cast, handle info, and then this is the new one, handle event. I'm pretty sure that the way this is implemented is it's probably a GenServer that extends to have its own callback module. And anything that matches the event shape and handle info is probably just sent to handle event down here. And then everything else is just passed through. I'm pretty sure that's how it works. I'm not 100%. But whatever. So remember, wxObject behavior basically means GenServer. You have an extra handle event. So if we look at the init function here, when we start this thing up, what we see is the wx server gets started. And now that's the C++ code that's like running. I believe it's actually running in the context of the Erlang runtime, which is why crashing, sending illegal things to the wx server will cause a crash in C++, but that's happening in the same system process as the Erlang runtime, and that makes everything go down. So that's why. But we have to get that thing started, spin up the wx code, then have wx make a frame. Remember, in wx terminology, a window on your desktop is called a frame. The stuff, like the container widgets inside of that, sort of the equivalent to a div in the HTML DOMs. Those are what's called windows in wx. So we start the window that you can see on your desktop here is a frame. Then it towards the bottom of this, we connect the frame to an event type called charhook. Now, the reason we do this is that window managers have like thousands of events going on all the time. There's tons of event types. Every time you mouse over something, there's like, it entered this zone event. The coordinates are here. The relative coordinate is this. The global coordinate on the screen is this. The size of everything. All that information is like flying around the system constantly. It's absolutely insane. If you got all those events, you just have like, you'd never catch up. There's so many messages flipping around the screen all the time, or flipping around the system all the time. So the default is to ignore these, to tell the window manager, don't send me notifications about all this stuff. So WX is able to listen for anything that it wants from the window manager, and it can elect to listen to any different type of event. Your own WX objects inside of your own graphical objects can kind of like subscribe to an event. That's what connect means. You're saying, if you're connecting the frame, you're saying, if this frame is in focus on the desktop and an event of whatever type I choose occurs, send me a message about it. So charhook, we're getting character key presses. The user pushes the key on the keyboard. That sends an impulse to the hardware. The hardware interrupts, and the kernel picks that up, and it knows, hey, I got a key press event. It tells the window manager about it. The window manager tells the window that's in focus about it. WX gets that notification from the system. Then it converts that, the WX Erlang part of it, converts that to an Erlang message and sends that to our handle event function. So that's the chain of events to get something from the outside. So we're listening to charhook, and we know that this is going to generate a key event, a WX key event. If you look in the documentation for WX, it's got every type of event that you can listen to, and the events themselves are represented by different types of records, each like category of events. So a mouse event has like a mouse, there's like a record for mouse events. Command menu events have a record type, because all the relevant, the data that's relevant to each different type of event is different. Like with these character presses, you want to know if like shift is held down or not. You want to know if control is being held down or meta or whatever. So there's like Boolean values that are in that, and those would not necessarily apply to mouse events, right? So like a mouse event wouldn't carry the complete status of the keyboard with it at the same time. So we're going to be looking for a WX key event, and we can find that. Well, let's go to, I'll just show you handle event. So if we look at handle event, we've got the previous thing we were listening to was WX close. I'm just matching on the record type because I don't care about what's inside of record WX close. If they hit the X thing, that's all I care about, and we're killing the program. This right here, this clause, the reason I'm showing you this is because there's an idiom here that's very easy to use for WX. When you get an event, make a handle event clause for that event type. So this category of events, these are all like whichever kind of events are related together conceptually. These are all movement commands, right? Movement commands are coming from the keyboard. They can rotate pieces and they can move pieces. We need to know the key code, like if they pressed an arrow key or whatever to move, or if they press Z or X to rotate, or if they pressed up to rotate right, and so on. Or if they press space to hard drop, which that's not implemented yet. Here we're using space to generate a random piece, but in the future they'll be able to hit spacebar to hard drop down. The quick, the instant drop in Tetris. So we match on this one event type here. We assign any relevant information inside of the record that we care about, which in this case is only the code. We don't care that this is a charhook because we're only listening for charhook, so we don't need a match on it. We don't care about the status of the control keys or shift keys or whatever. We don't care about any of that stuff. We only want the key code. So that's all we're going to match on. Then inside of the function, use a case to make a really simple decision table. What are you going to, how is control going to be dispatched based on this input? And in this case, we don't have any relevant state, really, to make decisions based on. Not within the GUI in this particular case. We're not opening a dialog. We're not showing a help menu. We're not doing anything like that. This is not a GUI-related event. This is a gameplay event. So we get the gameplay event. Then we have to dispatch an asynchronous message to tell the controller what happened. And the controller, it's up to it to make a decision about what to do. But we're not going to block on that. These are asynchronous messages. We're telling it that the event happened. We're basically, the GUI, this particular part of the GUI code is just a proxy for the system that's getting the information down to the controller. Now, we discussed in the previous video that you do want to have a separation between your GUI process, because it holds an external resource that could become locked up or go weird, and your internal control process, which knows your business logic of your application. And that could get weird or take too much time or whatever. So you don't want them linked together by blocking calls, if at all possible. I'm sure there's a couple cases where you're going to have a blocking call, but none of these, this entire game doesn't have any of those situations. So we're going to send a message to the controller based on what the key press event was. We're basically translating key code points to semantically important messages within the system. All of these are interface functions on etcon, and they just translate to gen server casts. So random piece, rotate left, rotate right, move left, rotate right, move down. And then this is just going to tell us on the screen like what was pressed, so that I can find out what key codes are if I want to use any other ones. Like, for example, if I want to use the arrow keys on the number pad in addition to the main little, the little T arrow keys on the keyboard, then I need to know those key codes. So I've still got this here because the game's not anywhere close to being finished yet. And if we look over at the etcon module, we see exactly what we expect. Move direction, gen server cast move direction, and that's it. That's the whole thing. And we just saw do move earlier, right? It's going to generate a new well and send a well to etGUI and say, show that. And it will. It'll redraw the entire screen every single time something moves. So that loop, remember, and this is an asynchronous call too. etGUI show new well, that's asynchronous. So they're not blocking, they're not waiting on each other. That cycle, we have an event from the system, we notify the controller about it. As soon as it's an asynchronous message, so as soon as we send that message to the controller, something happened, we go back to doing our own thing in the GUI world. The controller may or may not choose to send something back to the GUI to display or to do anything else. So that's what that commit was about. It was about handling character input, and that idiom, this idiom right here, where we match on a type and then use a case internally to figure it out, like how we're gonna dispatch based on that input. The reason I wanted to show this was it's tempting sometimes, depending on the coding style that you've adopted, to write a handle event clause for each different character code in each different situation that you might have for input. That becomes really hard to read, like very quickly, which is unfortunate, but it becomes very hard to read pretty quickly, because the more complex your application gets, you start having like tons of different kind of step down situations, and it's better to kind of block these off and dispatch out to the next branch point to decide what to do in a more readable way than trying to visually parse every single possibility that could ever happen in the program and match on each one of them in a separate handle event clause. So this is one of the few cases where I like an internal case like this. I'm not normally big on using case inside of a function if I could match in the head, but this actually works really well, and it's super compact and very tight and readable. Most of your decisions can fit on one screen at a normal resolution. Of course, I've got this blown up huge for the video, but you can usually see your whole, something like the entire thing, but you can usually see most of your input decision possibilities, how everything is dispatched, like at a glance. And that's very, very nice. And we'll see a couple of extra things because we add some menu commands that are mouse commands in a moment. Anyway, let's carry on. So that was unsafe movement. There's no boundary checking. Yesterday, all we did was talk exhaustively about boundary checking and collision detection and board clearing and line, clearing stuff up and all that. The next thing that happens is we add scoring and levels. And we removed the timer because I wound up just not... I decided that having a game timer wasn't very interesting. So let's check that out. Vim... Almost everything interesting in this one is in the controller, and specifically it's in the locked function. So if you remember yesterday, locked was like probably the most complicated function that we had. It's the thing that when a piece locks into the board, it has to check, are any lines cleared? It has to, well, so at first it takes the piece and it actually puts it into the board, so it's no longer a piece. The piece goes away. Each block of the piece is kind of deconstituted and put into the board itself. And that board, once it is locked, has to be checked. Every line of the board has to be checked to see if any lines are complete. If any lines are complete, then we collapse the board down. Based on the line count, we're going to generate a score. So this is a little bit different scoring than the previous one, but scoring is not even close to finished yet in this version. The important thing that we do here is we determine if there's a level that applies to this. So levels are every multiple of 10 lines. So every 10 lines, you go up a level. So we divide the number of lines by 10 and add 1, because you don't, like when you have 0 lines, you're not on level 0, you're on level 1, right? So we're determining what level we're on, and we're comparing that here. This is new in this one, in this commit. We're comparing that to the old level. If the new level is different than the old level, it means we've incremented it, and we need to update the delay. So the delay, that's going to be the tick delay. The tick is not implemented in this yet. This is just, I didn't know how hard it was going to be to implement the tick, the actual tick that makes the game move. So I started out by just wanting to focus on, let's play with this idea of scoring. Let's play with the idea of having levels. Let's play with the idea of decrementing the delay, and just see if that kind of works away, if that's an easy to understand thing, and if it's not too hard to make work right. So we've added now the updated stuff. Show the level, so show the collapsed well, show the level, show the score, show the lines, and then we send etGUI show updated. Now remember, in the previous version, we could only show the well. We would send the new well to the GUI, and the GUI would draw that. Now what we're sending is a list of elements, a list of different types of things that it can draw and show on the screen, to include score, what level it's on, what the well looks like, and so on. So I just kind of use this show function as a thing that receives a list of stuff to show that's tagged by its type in a tuple, and based on that, it knows what to do with it. And that just wound up kind of being an easier interface. I could write a separate function like show well, show level, show score, show lines. It's, calling all those separately. I didn't really care. So this is the way I did it. There's 100 ways to do it. This is just the one that I chose. So this is a new element in this commit. We didn't have a new level before. Now we do. And this stuff works as before. We generate a new piece, and we tell it to show the occupied points, and the new count is the new number of how many pieces have been used so far. And that's that. If we go over on the GUI side and we look at show, let's see how that's changed. So if we look at the spec for show, we can show the well just as before, but now it's a tagged tuple. We can show the vacated blocks, which we know would need to be drawn black with the X sprite. We can show occupied of what type and a list of coordinates. We can show the level, which is just integer, score. All these are just integers. So show the level, score, lines, count. That's only telling the GUI like which display box it goes into, because we have some text elements on the screen that we're going to show. So if we get down here, the way show works is show this list of elements. We make a little thing here, do show, and lists fold show state elements, and that's it. This actually can go away. We didn't need this. I think as I was developing this initially, I had some state that I had actually, I think I was pulling the frame out, and I put that in do show. So I was closing over it. So this used to be a closure, and then I realized I didn't need that. I could just pass the whole state in and update that and fold over the state. So now that we can get a new state back from do show, it used to just be a stateless function. Now it's a stateful function. So this lambda is actually not necessary. I can just reference do show right here, because it is the correct arity. There's no difference between show and do show. I've just got an anonymous function reference over it for no real reason. So that can come out. Anyway, the idea is that we're going to call that function do show over each element and accumulate anything new in the state as we go, get the new state, update at the end of it, and then return a new state. So what we want to see is we want to see do show. So it's pretty straightforward how this goes. Show the well, show the level, show the score, lines, count, and then occupied and vacated. Those do the drawing routines that we discussed previously. They fill in the points to get the new well, and then they draw the new points in the well. Drawing the well calls the old draw well function. This used to be kind of the whole thing of do show used to just draw the well, and it just returned okay. That's why we had made that closure, was to include state and for all this other stuff. But now we're actually updating state. Except that this do show clause right here to show the well, it did not used to return state. Now it does. And in that, I made a mistake here. I'm not updating the well, which means that if we get a paint event, like if someone stretches the screen out and our graphics context goes away and needs to be repainted, or someone like moves, crunches the window down too small and they jump it, they expand it back out, so half of it's like missing, we can't redraw because we have a stale version of the well. We're not updating the state with the new version of the well, so we can't actually redraw it. Down here, we do it correctly. We update the well, and we add the new well to the new state. Up here, we're not updating state with the well, which is dumb. So there's a weird display bug in this particular version. But what I wanted to show is that the do show function becomes this function that winds up operating in a fold over the elements that are passed in, and it, some of these update state and some of these don't. But the final state is returned. Each one of these different things returns state. This one just returns the wrong one. So anyway, now remember, I did all this stuff just to determine how I wanted to do scoring, line counts, and make sure everything kind of worked before I got onto the task that may be hard, which is implementing the tick. It turns out though that implementing the tick was like totally not hard at all. So this commit right here, the next one, adds the tick. So the game actually plays now. I adjusted the scoring a little bit because I really like in Tetris when it rewards you a lot for getting multiple lines. Like especially if you get 4 lines at once. I love it when you get a big bonus on that based on the game being very fast at that moment. That's always been one of my favorite things about Tetris, is challenging myself to get 4 lines at a very high level. So I've kind of updated this to give like an exponentially awesome score bonus for that, based on how many lines. And we've added the tick, and we've added a pause. So there's a pause function. You can hit the pause key on your keyboard or press P on your keyboard, and the game will pause for you. And so those are both, all that stuff's implemented in this one, and we're going to look at that now. So, God, I keep mistyping today. All right. So, we have new game, pause, and unpause. So, new game actually does something now. If we look at the state record, this is the controller code, right? This is not the GUI. If we look at the controller code, we have a new thing, timer. Timer starts out as none. It has a reference, and it has a paused condition that can occur. This is actually the remainder of the previous timer, so we can restart the timer wherever it left off, instead of just being able to press pause and flicker the game forever. So let's go to new game, do new game. So do new game, we're going to take the timer, because remember, somebody might be playing a game and decide they've had enough of it and start a new one right then. We don't want to crash on that. So if the timer is none, then we just return OK and start a new game. That would be the first time you play. If we do have a timer, and there's other ways I could have checked for this. This is just the one I chose. We're going to cancel the timer and then go do whatever we were going to do to start a new game. So to start a new game, we're going to establish a timer with a tick. Now, the first level 1, has a 1 second delay. That's 1,000 milliseconds. So this is a cool function right here. If you're not familiar with Erlang, this is one of the kind of secret weapons of implementing lots and lots of interesting time-based behaviors in Erlang, is Erlang send after. So after 1,000 milliseconds, the runtime is going to send us, self is a built-in function that gives you your own PID. The PID, the process ID for whatever process is executing this particular call, send myself the message tick. So we're just going to get a naked message. It's just a naked atom tick. So that's going to pop up in this module's handle info. We're going to match on that and take an action to actually do a tick. And we'll see what has to happen at a tick in just a moment. Next, the next piece that we want, we're going to determine that right now by calling piece, get a random piece. We're still setting an arbitrary location. That gets fixed later. So these magic numbers aren't really good, right? And we have a new state record. If we're starting a new game, none of the previous state matters. So the old score doesn't matter, line count doesn't matter, nothing. We're just wiping all that out. We've made sure that we've canceled the previous timer. Because if we don't do that, and someone's playing a game, they start a new game while they're playing the other one, there's a tick message waiting to go off, right? And that's in the runtime. It's not in this process. So if we don't cancel that timer, they start a new game. And if you don't cancel this one, starting a new game would generate a new timer. So now you got 2 timers waiting to go. So this tick is going to go. It's going to perform tick. And then that performing a tick will generate a new timer, right? So that's out here. Then this timer is going to go off. So your average is going to be half of 1,000. You're going to have 2 ticks every second, which makes the game twice as fast. Just to start with, which is not good. If you do another new game, now you'll have 3 timers out there. So you got to cancel your timers. Any active timer you've got, you got to get rid of it before you start. So that's the reason that this is here, and it looks funky, but you have to do that. Otherwise, your game is crazy. And this goes into a completely new state record. Now notice, we are not drawing anything to the board. We're scheduling a tick. We're deciding what the first piece in the game is going to be, which will come up next. And then we're just going to go back and wait for this tick to go off. So when you start a game, it's not instant. You're waiting like 1 beat before things get going. And if you've played Tetris before, that's a pretty typical way to implement stuff in Tetris. So what we need is to check how are we handling, what are we doing with this message? So we go to handle info and we see the tick thing. And we're just going to go to do tick because that's, you know, what you do. Do tick. If there is no piece, remember we have a fresh state record because we just started the game. There is no piece. Piece is none. The next piece is in the next value. The delay is here and the count is here. Now, there's two cases where you might wind up in this clause. If a piece just got locked into the board, that piece just disappeared, right? And you want to pull the next one out. Or if you just started the game, you don't have a piece to start with, so you pull the next one out, which is what we just determined in the do new game function. So if we just got a tick, we know that that timer is dead. It's gone. We don't have to cancel it. It's gone. So Erlang, send after this delay to myself the message tick. That's the first thing we do. We're saying we're scheduling the next tick based on a delay. Now remember, if the board had just, if we just locked a piece in, if we just cleared a bunch of lines and we went up in a level, that delay would be different from the previous delay. So that's how this is carried on. You know, how we continue advancing the game is this clause right here handles all of it for us. We get the type of the piece. We get the points, right? By getting the type of piece combined with the offset is going to tell us what points, you know, how to draw that on the board. We don't have any vacated. We didn't vacate any blocks because we didn't move. We've got a new piece count because we're adding a new piece. We're going to show the new count and show the occupied points where that piece is. So display this on the board. Get a next piece, generate a next piece, and update the state record with all that stuff. Now, if this is not true, we're going to do tick. With state, we don't want to match everything in here. We're going to make move. And that we could do this delay here, send after. We could do that on the first line if we match delay. But there is a possibility that the tick locked something into the board. Maybe that cleared a line. If that cleared a line and advanced the game, delay would be different, right? So we don't want to compare delays. We're just going to get the new one after make move is called. Now, make move is the same thing that we were calling from the GUI. If someone presses the down key, it calls make move down. The tick is just going to call that same code. We're not going to rewrite it. We're not going to write anything magic for tick. All we're going to do is pretend that what tick causes to happen is it's just like the player pressing the down key. And we already know all that mechanic works. So we actually don't have to do any extra work here. So like that's it. That's why I was saying like tick wound up being actually easier to implement than I had anticipated, because all we have to do is simulate a key press. A single key press down is all that we're doing, and then get the new delay in the event that that actually made us go up a level, and then use that to create next tick. Now, I'd said if we lock into the board, we're going to come back with no piece. That means that if we go into locked, what we should see here now is that piece is now none. So if we get a piece locked into the board, piece is going to be none because it's gone now. We already have a next piece in here, right? It's already in the state. I mean, we're not matching on it, but it's already in this state. So that's going to go, you know, that's going to go into the do tick function, the next tick timer that fires. And there's a timer already waiting on this, right? So we've assigned piece none. That means we're going to get that first clause of do tick that matches on none that generates the next piece and so on. So that's it. Like that's the way this works. So if we do this now. New game. Cool. Now, if I press spacebar, hard drop not yet implemented. See? We can't hard drop yet. But we can play Tetris just kind of a more boring way, where we wait for a long drop instead of doing a hard drop. And that's just, it's not a big deal. But this works the way you would expect Tetris to work. This is basically Tetris right now. The scoring is still a little bit weird. There's details, of course, of gameplay, like not having hard drop is very weird. But that's like pretty much the main thing that we're missing at this point. This is, for all purposes, a Tetris implementation. It's just not a great one yet. And that's it. So, see, the score is like really, really low. I've cleared a couple lines. I'm doing fast drops and the score's not really going up much. We're going to see that gets adjusted in just a moment. But this commit right here, add pause, new game features, adjust scoring, that's basically Tetris. Like at this point, we can basically say we've created a competent implementation of Tetris, but it doesn't have anything really nice happening yet. So, and there's one thing that we don't have at all, which is we do not have a game over condition, which is really stupid. So, if the game piles up to the top, it won't actually end, which is dumb. So we need to add hard drop and we need to add a game over condition, or else we don't really have, we're not quite there yet. So hard drop turned out to also be a lot easier to implement than I had expected. So remember bottom. If we get bottom for the motion, if someone hits spacebar, we want, not controller, we're going to go to the GUI. This is what's going to happen now. So in the handle event code, remember 32, it used to create a new piece, right? A random piece so that we could test, and like a few commits ago. Now we've changed that. Hitting the spacebar is now going to be bottom. Bottom being the fast drop all the way to the bottom. So if we look over here, we've got bottom and move. So if the direction is bottom, this changes now. When we do move, every time we move, we need to reset the timer. We need to cancel the existing timer and start a new timer. Now, this was in the previous commit also, but I didn't show it. So first thing we do is cancel a timer. Then we're going to set a new timer, because the remainder of the previous timer should not affect. Like if you hit down, it shouldn't go boom, boom if the timer was just about to go off. It should only go down once, and you should have a full, you beat the timer going down. So you should have a full fresh timer to start from again, instead of being kind of tripped up by like a double fire there, a double movement. So cancel the old timer, start a new timer, then make move direction state. Now, note that here, this clause where we're resetting the timer only applies if the direction was down. So if we're going down or if we're going to the bottom, in those cases, we're going to reset the timer. But if you reset the timer every time you move at all, if you do like left and right, if you're resetting the timer, you could float around forever by just hitting the left and right keys. And that would kind of defeat the purpose of the game. So we're going in both cases, we call make move, but now we have a special one. Up here, we cared if it was down or if it was bottom. In this clause, we only care if it's down, or if it is bottom specifically. So make move bottom, we're going to do two things here. We're going to give a score bonus for having done a hard drop. And the way that bonus is going to be calculated is based on how high up you initiated the drop. So if you're at the very top and you initiate a high drop, you're going to get a score based on the elevation up. like how high in the well you are. So we're going to get the score out at the beginning. We're going to hard drop. I'm sorry, we're not getting it out at the beginning. We're going to hard drop with the existing state. We're going to get the score out because a hard drop may have caused the score to be updated. We may have cleared lines, right? So we want to get the new score out. That's why you've got this kind of complex match, which is like what we did before with the delay. The delay may have been updated. So we matched this. We just extracted score from the new state in the middle of a match there. So this is the new state variable, and we just kind of plucked score out of it in the middle of this kind of assignment chain. So we want the new score, which is that. We want to know the height of the well, and then we're getting the location, because this was the location at the moment that the spacebar was pressed. We're going to multiply the level by the height that drop was initiated, and we're going to update the score by that amount. We're going to add that to the score, and then we're going to tell the GUI to show the score. And that's it. That's, how hard drop works. But hard drop, that's how the scoring update works. The hard drop itself, I had not really, until this point, I hadn't thought about how to implement hard drop. And I was thinking, God, do I want to take every different lateral profile of the bottom of the piece and calculate how many blocks down there are, and then warp that many forward, and then lock into the board and so on. And I was thinking, yeah, that's kind of, I could do that, but it's kind of ugly. Then I thought, well, what if I just loop over make move until the piece is gone? Because when we lock into the board, the piece is gone, right? So I can just check the state to see if piece equals none. If that's true, then we're at the bottom and we can stop looping over hard drop. So that's exactly what I did. I wasn't sure if it would be efficient or not, because remember, every single motion thing, every single motion command will tell the GUI to update, redraw the screen. But our redrawing is actually pretty efficient now. So it turned out to work without a hitch. And this was like one of the sounds kind of hard if you think about it, but turned out to be very easy to implement features was hard drop. So hard drop, we're going to make move down. If the new state has none for the piece value, then we're finished. We return a new state. Everything's already been calculated because we already wrote all the mechanics. We already wrote all the rules. We're already updating everything that we need to. So we just need to return a new state. If piece is not none, then we're just going to call hard drop again with state. It means that we're not at the bottom yet. So it just loops over this real quick, and that's hard drop. That's the whole thing. And remember, we called hard drop before getting the score out in case this cleared lines or something, and we update that. And so the new score that goes back to the main loop is properly updated because we already wrote, all the work has already been done to do all this stuff. So hard drop actually is really, really easy here. The other thing we've got is in the GUI, we have implemented pause. So here, if they hit the key P, the P key is 80, we're going to pause the game. If they hit the actual keyboard pause button, they're going to do pause. Now, do pause, this actually does have a GUI component to it. So we're taking the frame out because we have to show something, and we have to call do pause with that. So the reason is we're going to show a modal dialog to kind of freeze everything. So we're calling the controller and say, hey, pause. So it can do that. Caption. So a message is going to show on the screen. We're going to show a modal dialog with the title pause and the message game paused. We're going to make a dialog box. It has to be a child of the frame. It's going to carry this message and options, the caption for it's going to be pause. Then we're going to show that dialog, and we don't care. It's going to have like an OK click box on it, and I think like an X thing or whatever. Modal dialogs can return arbitrary data to you. We don't care what the return value is. If the user makes the box go away, then we're done. Like we're not going to handle any data from it. So we're assigning it to the I don't care variable. Then we're destroying the dialog box. Then we're calling unpause on the controller. And over on the controller side, we'll look at do pause and unpause together because they're super, super simple. Do pause takes the timer. If the timer is a reference, we're going to cancel the timer. And we're going to actually assign, for the first time, we're assigning the value of the canceled timer. When you cancel a timer, the return value of that function is the number of milliseconds remaining before it was going to fire. So we're going to pause it and remember how much time was left. If we get unpause, so if it wasn't a reference, if there was no timer or something, and someone pressed that key, we're just going to ignore it and do nothing. If we get the unpause message and the timer is that tuple, the magic tuple paused, and then how many milliseconds are left, we're going to create a timer, send after the remaining, the remaining milliseconds to myself, the message tick, assign it to T, and we go on. If we're not paused and we get an unpaused message, we're just going to ignore it and carry on. So that turned out to be very easy to implement also. Let's look for a second here at, let's see. So we had connected to Charhook before, and we were always connected to the close window thing. There's a new one here. Command menu selected. So command menu selected, that means if you have a menu, we have menu items in here, right? New game, exit, instructions, about. These things here are menu bar items. So we've created two menu drop downs. The game menu is like, it goes in the same place that you'd see like file on most applications. There's a file thing up there. We're just making it called game because, you know, it's simple. Then we've got inside of it, we're going to have, so it's a child. This is a menu item. A child of that is going to be the new game option. A child of that is going to be the quit option. A child of help will be the instructions thing, and another child of help will be about. So those are the command menu selected options. And that stuff, you know, I put the most frequent stuff up at the top. I typically do that. So remember the wxClose command, it actually is down here now, because it's the least frequent thing you're going to get. If you get one of those, the whole thing's over. Paint is also infrequent. This happens all the time in the game, so we've kind of put the focus on that by putting it at the top. The next most frequent thing will be command menu selected, and that's it. So wx command. There's a whole wx command is a whole world of possible events. The type we're looking for is command menu selected, and again, we match on this type in the event here. Handle event here, then we have a possible update to state depending on what's going on. So game new, call new game. Help instructions, show instructions. Exit, go to close. So we've actually abstracted that out. Like the stuff that used to be inside of the wxClose event, that's now pushed out to a separate function so both of them can call the same thing. And then about, show about. If we go down, I think these are the bottom. Yeah, so close now just does the kill the program steps. So do pause, we saw the modal dialog come up and then, you know, go away. Show about is the same thing, except it doesn't pause the game. So actually, while you're playing the game, if you click that and you and you show about, the game would keep going on behind you. Really, it should pause the game, but I didn't do it that way because I didn't think about it until just now making this video. So the version, we want to get the version for the About menu. We're going to get the version from module info attributes because ZX is going to keep all of our version strings up here synced across all the modules. So any module is going to have the accurate version number. And we're just going to get our own module info. Module info is a built-in, it's not a built-in function. It's module info is a function that gets built and exported from every module that the compiler builds. So this is calling this like my own modules, module info attributes, and then I'm getting the version value out of that, which will tell me that, and it's going to come out as a string because that's what it is at the top. That's like that that module attribute is you know, a string. So we're going to format it as a string here to make it look pretty. So the screen's going to say Erltris version whatever, a Tetris clone in Erlang, author blah blah blah, me, and that's it. It's like this is just a basic informational screen. Most programs have this, especially open source programs usually have this. And we just have to format that version to get the message string that we want out of it, then the caption, and we're going to determine a style. The WX styles are if you look in the WX project itself, not in the WX Erlang, look in the WX project documentation, you'll see all the different styles that are available. All those are available, are aliased to WX constants, you know, macros that are defined in that WX header file. Read through that header file if you're new to doing WX Erlang stuff, and read the WX project docs also to kind of get some idea what styles are available for different dialogues, text types, and stuff like that. If you mess around with them, it's pretty easy to get things to work, especially if you've ever done WX like in Python or C++ or something. Anyway, we're going to make a new dialogue, show the message. We don't care how the user kills it, destroy it, return the state. This is real simple stuff. We're only getting the state to get at the frame. So show about works that way. Show instructions, it's the same thing. The exact same steps up here. If I had 2 or 3 more modal dialogues that I needed for the game, I would just remove all this, and I would let that would be in its own function, and I would just be passing the message in the header in because everything would be the same. So you can very simply abstract out the process of showing a modal dialogue, which actually I have a library that I've sort of been working on for a long time that is I call meta widgets. So there's a ZX, this is wxWidgets, right, that we're using. I've got a thing called wxWidgets, and it actually abstracts all this boilerplate stuff away. So if I use wxWidgets, I would do like zxw show message and then just whatever the message is, and it does all this and just shows you the thing and throws away the result. Because this is a pretty common like user communication thing that you do, and learning about how to get all this done, it's important in tutorial code to show all this, but when you're actually writing production code, you don't really want to write style and WX icon information, junk like that all the time. So anyway, let's see how this guy runs. So now we do new game. Instead of just hitting spacebar to start or just having it start automatically. Now hard drop, so that we're looping over every, hard drop is just looping over every single possible drop motion that we could have done. And this is starting to work the way that we would really expect Tetris to be, right? This is much more like a standardish implementation of Tetris that you know, feels pretty similar to the Nintendo Tetris. Now there's something weird here, which is if we pause the game and unpause the game, look at that. Remember I had said before that when the repaint event occurs, which these are repaint events right now, and see that like it goes through the board, which is weird. That's because the GUI right now has an inaccurate view of what the well is, and it's not part of gameplay. It's got no idea what the truth is until it gets that refresh event. So until we actually manage to clear a line, we're not going to have an accurate view of the board. Now it's accurate, because we had the old board mixed with the new board inside, the well. The old well was mixed with the new well positions, so the collapsed lines were all just smeared across each other until we clear a line and we actually sent a new well update to the board. So our view of the well is inaccurate on a repaint event, which is that bug I told you about before. We fixed that in another commit. So we just added hard drop. We still don't have a game over condition. We do that here. Oh, so this commit up here, fix display redraw bug, that actually is that well assignment. That's all. I think it's like a one-line commit. It's just updating that well state. So add game over means, I think it's in do tick. Yeah, here we are. Okay, so remember, if we're doing a tick and the piece is none, if there's no piece, then we're going to pull the next piece out, put it into the board. When we put it into the board is the moment that we can check, are the places, the coordinates that we're supposed to populate with this new piece, are they already occupied or not? So remember, in the previous video, I had said that the do rotate check, it combined both the boundary and the boundary check and the collision check in a single check, right? And I'd said, well, that was kind of neat. But in the movement one, I had split them apart. There's a boundary check, and I used the sides, the action box range for that. And then separately, we checked for collisions. And I said, I didn't know if I really liked that or not. Well, it turns out that I actually needed that because I need an independent collision check. The reason I have to have an independent collision check is because when we put a piece into the board, we have to check if there's any collisions at all. And that's what we're calling right here. So again, once again, implementing the game over condition. If at first you think about it, you're like, wow, okay, so I got to figure out where all the pieces are and then check the board if all those are done. And what? Well, it turns out there's nothing to worry about. That code is already all written. If we get our new state, this is pretty much the same do tick function that we had before, right? But now we've got a new thing. We already painted it on the board. We're already showing the new occupied points, right? The last step we're going to do is we're going to check if our points, if these points that are occupied, remember we get the new piece, and oh, here we're getting the width of the well and we're generating a location, which is a little bit more advanced than the canned condition that we did before. Anyway, we get the points for that location, wherever that piece is going to be. Then, at the very last step after it's drawn on the screen, because it may have overdrawn something, which is good, right? That's how Tetris usually ends. You get that overlapping crunch, crunch, and then, the game's dead. We're going to check, as a last step, if adding that piece to the board actually was a collision. If it was a collision, remember, the collision function can return stuck or locked. In this case, there's no down motion. We're pretending that our motion is P, which doesn't exist anywhere, right? So it's just a garbage thing. It doesn't matter. If the result is that we are stuck, then that actually means the game is over. So we're going to cancel the timer that we just set. We're going to sleep for 1 second because we want to let that crash like the guy died. Just let the thing sit there for a second. Then call the GUI and say, do the game over routine. And game over on the GUI is really simple. We wipe out the state. Well, no, we don't. we keep the well the way it is so that we can show it, the final status of the player. And then we just sit there and wait, because a new game wipes everything out and redraws a blank well and resets all of the values that are in the the score and the lines and all that stuff. So all the data just goes away at that point. And then we set timer to none because we do not have an active game going, so we don't need ticks. And that's it. That's the game over condition. So game over turned out to be really, really easy. It was just pretty much adding this stuff here. So the next commit, I updated the Zomp metadata because I was going to actually commit it into the package repository so that people could play it. Then after that, I versioned up to 1.0. When I added a next window, that was kind of the last feature that I was waiting on doing, was adding a next window, and that turned out to be pretty easy also. For the next window, that's mostly GUI stuff. We'll see the difference here if I run this. Now we have a next window. And when I play the game, now we get the next piece coming in is shown. And again, this is completely random. These are totally random piece choices. So you can get repeated pieces over and over, and the game can totally screw you in this version. There's no safety boundaries for this one. It's also not asshole Tetris where it tries to give you the worst possible piece all the time. It doesn't do either one of those type of calculations. So our next, this is a pretty common feature in Tetris games, and we've got it implemented here, which is kind of cool. The way that came out was mostly in the GUI, and we'll see what happens here. In the init thing, the first thing we do is we create a next box and a next a static box, which kind of draws that outline with like a label on it. That's where this gets put in there. We create a static box sizer to put that in. Then we create an actual panel. Now remember, panel is a thing we can draw into, which is just like the board, right? The board is a panel, and the next box is a panel. And the next box is going to go into the sizer for it so that it shows up in that same list. All these things look the same, right? This is just the kind of unique one because it's not a text thing. It's something different. We know it's going to be 6 by 6. I could have derived that, but it doesn't matter. So these are just kind of magic numbers. We know it's 30 pixels by 30 pixels, so we just set it that size. Then what had to change in here to make these work right is I had to set expansion proportions to make all the text things expand to the size they should be at proportion 0, which means they're going to expand to fill the space, but they're going to be as small as they can be independently if anything else is pushing on them. And the sizer, we're going to expand it to proportion priority 1. So it's going to take up all the remaining space and make sure everything's kind of nicely stacked at the top. So all this stuff, the expand, proportion, whatever, that's all new. Then we just add the next sizer to the stat sizer. And that's it here. And that's it. Now we have a new panel that we can draw things in. And we've already got all of our drawing functions because that's how we draw the main board anyway. So instead of doing something special here, we just made a mini well, and we're going to just put a piece in the mini well at a location that's in the middle. And that's it. So if we go to show, show. Okay, here we go. Remember, we've got do show. That's the one I should have gone to. Okay, so new game. See, new game just wipes out all the data. It resets everything to 0 and 1. And the new well is just blank. So then we just show everything. Show next piece. We're going to create a blank well. We'll get the type of piece. Now, I'm just making this up. That it's a 3x3. There's no real dead center, and the line piece is actually longer than the other ones, so it fits funny. So we don't really care. It turns out not to actually look bad visually anyway. But we just create a mini well, 6x6, a little tiny one, and we've already written the function for that, so there's nothing new here. We've already got this stuff written. We already know how to get points, and then we just call fill on the new well, and then we draw the new well with the sprites. Because the draw function already gets the dimensions from the well and knows how to do everything by itself. So that was it. This is the entire thing, really, that had to be done, other than adding a place for it to be drawn. Again, drawing a next piece, when you're coding, you're like, I don't know, maybe that's going to be a pain in the neck. But as you look into it, you realize that you've already got a well-defined data model. You've already got operations over that data that are not crazy. You've already got all the functions necessary to do this. So you can just use what you wrote, and you're only adding a couple of lines to add a really nice new feature. And that turned out great. So I added the next window, and I decided that was good enough to go ahead and push up to version 1.0 because I liked what it was. Then I fixed the display redraw bug, which we saw. Not ZX, Git. Right here, draw well and then update the well. So this actually fixed that bug so that if we clear lines and then pause or get a repaint event, we'll get an accurate depiction of the well again, which is what we want. So that worked out really well too. There's a crash that I had in this. If the timer is none and we get a move event, because if the piece was none and we got a move event, we would disregard it. Also, if the timer is none. So like what would happen is if the game is over, you still have a piece on the board and you still have a next. Those things still exist. If you hit a key press, then the GUI is still listening for key presses. It's going to say do move. And you can actually have a piece in state, but not have a timer and then try to call cancel timer. And that, blows things up. So that was one crash that I fixed. And now remember, this is like GUI code, and I know there's all this test-driven development and whatever. Property testing is really useful. Fuzzing a system is useful. Integration tests are useful, and user testing is useful. Unit tests that are handwritten tend to not be super useful in this type of code because there is no test you could write that would tell you that. You just have to have somebody play it and find out, like, oh, that blows up. And then you look at it, and it's obvious why it does it. It's crystal clear why this is happening. So it's not hard to track down and fix. But these kind of things are, these are user-facing obvious bugs that you can really only figure out by having someone mess with it and, give you a report. So extensive user testing is good. And that's one of the reasons why if you're writing games, even simple little dinky games like this, play it yourself a lot. Have your kids play it. Do whatever, like your friends should play whatever you're doing, whatever you're writing. For two reasons. One, if it sucks and you don't know that the experience sucks, then you need to know that. Second, if you've got crash bugs like this, you got to find them. And they usually stick out really obviously. And like 90% of crash type bugs in GUI code are going to come out like real quick. You've always got 1% of Heisenberg bugs out there, and you've always got some percentage of little weird obscure bugs that can only happen in a really special condition that are repeatable. They're not Heisenberg bugs, but they're repeatable. But it requires some really wild situation that only a power user would find out about, or would just occur as a fluke one day. So this is a good example of the kind of bug that you can't test for. And the code would pass all the tests and it would go out in the wild and it would still have a bug in it. So you can't, in abstract code where all your functions are pure, your test can catch the stuff, especially if you're doing like property testing and you've written type properties. But in code where you start dealing with the real world and you're dealing with user input and you've got, you're dealing with layers of different frameworks and different languages so that you can do GUI stuff or audio output or graphics or whatever. You can't catch everything with testing. So keep that in mind. When you're writing GUI code, keep that stuff in mind. Simplification of complete line check. Yesterday, I had mentioned, this might be kind of fun to see. Yesterday, I had mentioned that the complete line check, I don't know if you guys can see that. The complete line check was matching internally on the line checking function. It was checking whether or not the list of line numbers that had cleared was empty or not, and then converting that to the atom none and returning that value. What I did in this one was down here in locked, the locked function that we started out this phase of the discussion on. Previously, I don't know if you guys can see this, we had matched on none. We switched that to matching just on the empty list. Then completed prompts calling the etwl collapse function that used to just return the collapsed well, and then we would check the length of the completed lines, and that would be our line count, and that's what we would use here. In this one, we've changed things around a little bit. So the collapse function, remember previously in the old one, we started at 1, ran up to the width. So we counted like X and Y start at 1, and we would advance X until it was the width, and then loop back over. And we were doing the same thing with Y. We would start at 1, and we would go up until we had reached the maximum height, doing all the checks, and accumulating a list of all the lines that we realized were cleared. Now, what that wound up doing, because of the way that lists are accumulated, when you append stuff to a list, you append it to the head, right? So we're starting from 1 and counting up to 18, which means that the low line count numbers are at the end of the list. So we wind up having a list that goes like, if you cleared the bottom 3 lines, it would be 18, 17, 16. And so the order you would encounter those if you loop over that is 18, 17, 16. So when we clear the lines, if we just loop over that list as it is, we would clear line 18, then move everything down. Now we have to advance the index number because all these lines were just a moving target, the ones we're trying to get rid of now, the ones that we want to blank out. So we had an accumulator that was counting the offset. We want to clear line 17, but it's moved down 1, so now that's line 18. And we have to keep track of that offset as we go. Well, I decided instead to just simplify it by making that list accumulate the other direction. So instead of starting at 1 and counting up to the width, we'll just start at the width and count down to 1. What that does is it makes that list wind up being the lines that were cleared are lines 16, 17, 18 instead of 18, 17, 16. So now we're going to encounter them when we clear the board, we're going to clear in order from the top to the bottom. That means that as we remove a line and push everything down, we're just going to the next line anyway, and we don't need the offset anymore. But we actually want to keep, I'll show this here. So complete, previously we had the height, width and height here, and we switched it, this is reversed here, because we want to play with a Y value. This had the height value in it before, and we were comparing if Y is less than or equal to the height. Now we're starting at the top. We're starting at the max height. And if y is greater than or equal to 1, do this check, and then subtract 1 from y. So we're just going to decrement instead of increment. But that gives us this effect of reversing that list without having to call list reverse. We just naturally get that list in this order now. So changing that order means that the collapse function can become simpler. We don't have to delete the element, then insert an element, then, delete an element at an offset, then insert an element at the head, then increment the offset. So we don't have that offset calculation anymore. But we do want to have a count of the lines. So the thing that was getting an offset was also actually giving us an accurate count of how many lines were cleared without having to iterate over the list just to get the length, which we had been doing here, right? So it just turns out that this fold can return the crunched down well, and it can return this tuple, the whole tuple. Before we were pulling element 1 off the well, we were pulling element 1 off of that accumulated value because we didn't care about the offset. But it turns out that the offset value would have been already the line count. So we kept it in this version. We no longer are pulling the first element off. We're returning this complete tuple, which comes back here, which has already got the collapsed well and the line count, and the collapse procedure is actually simpler now because we don't care about the offset. So it has become less confusing with a little bit less code, and it's just an easy thing to do. And there's fewer variables in these heads doing it this way because we're not having to carry the width extent. That variable's gone. Same thing. We're not carrying the height extent. That variable's gone. So this has been a nice kind of simple thing to do. So this commit here, that's what all this is. Looking at the commit message, simplification of complete line check. That just made everything a little bit less weird, and that's nice. Any kind of simplification like that is a nice thing. And then I increased the patch version, and I released this to Vapor or Zomp. So now if I do ZX run Vapor, and we scroll down to, we got Minesweeper here, Barnsley's Fern, Erltris. If we click the versions of Erltris, we see we've got that original kind of weird version. Then we've got version 1 that introduces the next window. And then we've got the display correction, fix, and the simplification. All that's in this 1.0.1. And we can run that. And this is the game that we want. So this is, I'm satisfied with the way Tetris came out here. There's a couple of things in there that, could be made a little bit nicer. But it's not that big of a deal. I'm not too much of a, this is like a simple puzzle game. I think there's more weird stuff lurking in the Minesweeper code, actually. So this is, I might do a video explaining how Minesweeper works. But this is Erlang Minesweeper. And I might do a video on that if people are interested in it. But anyway, writing GUI games in Erlang is a very doable thing. It's really fun. Using ZX to do it makes it a little bit easier than, it makes it easier to write, a little bit easier to develop than it used to be. But using ZX and especially using Vapor for end users makes it way easier to release. Because, I run my own domains. I run the OTPR repository, so this is a little bit easier than me for most folks than most folks. But like the steps to release something. Oh yeah, that's okay. So if I ZX. Yeah, so this version already exists, so it's not going to let me package that right now. But the way that you do this normally is ZX package Erltris. You target that directory, and it makes one of these. this is I deployed version 1 from here, from this computer. So this package is still sitting there. And I can't resubmit the same version. The Zomp repository is write only. So you can't duplicate something, you can't overwrite a package or something like that because all the hashes are already in there. If like my keys are on this computer and everything, so if I just do package, it'll just generate the package, sign it, and then I can submit. There's a submit command, you submit it. Then anybody who's a maintainer, if you're just a developer, you cannot approve your own commit. Anybody who's a maintainer or system operator, they can review a package that's pending. You can list the pending packages. The review command, what it does is it downloads this ZSP file, which is the bundle. It's like a tarball with some extra meta that and some signature stuff that is the whole the code bundle, and it will unpack it in your directory, like where you're at, and let you experiment with the code. You can do ZX run local, and it'll set everything up the same way that it was on the development machine, which is the same way that it'll run on a client machine. So then once you're confident that you like that commit, you like how it is, you go back and you sign that. So if you are the maintainer of the repository, or the maintainer of a package that's in a repository, if you have the maintainer authority, you can do approve that package. And to approve that package advances it in the, there's 3 phases. You've got submitted packages, you've got approved packages, and then accepted packages. Only the system operator, the guy that runs that repo and is responsible for whatever comes out of that server, he can accept it. And the acceptance thing, he does the same thing. He'll review it, which brings it down for him. He'll get that ZSP package on his local system, and he's going to re-sign that with his own sysop key before he puts it up. So the packager keys and the developer keys, those are different than the sysop key. So the sysop key accepting that package, that's when it's finally published, and it becomes available, here. So this is like this version 1.0.1, that would not be visible to an end user until it's accepted. So submission, approval, acceptance. So submission by developer, by a developer authority, approval by a maintainer authority, and then acceptance into the repo by whoever the sysop is that runs that realm. So I run this one, the OTPR realm, because I wrote ZX and Zomp. That's like the default realm for open source code or whatever. But you can stand up your own realms, make your own keys. You can do all your own thing, and you can mix and match dependencies across realms. So it's that makes it very easy in if you have like a large service infrastructure that you're inside of, instead of going through like the CI nonsense to try to get things to work, you can have a private realm and use external dependencies. Every time you pull an external dependency in, that will get cached on your Zomp server internally. So from that point, you don't need any external communication from the outside. You've got your dependencies locally, as long as OTPR repo is, or any external repo or realm is configured on your Zomp service locally. And then you can serve things locally exactly the way that I've been doing this development here. Push it up to your local private, externally invisible realm, and then any system inside of your infrastructure that has ZX on it, you just do ZX run whatever, and it just pulls stuff and runs it, and that's it. So it's a little bit easier for this type of development, especially for end user GUI code. It's easy for server stuff too. There's still some things about daemons that I kind of I still handwrite, demonization, which I shouldn't do. I should make like a ZXD function that properly demonizes something right away. It just hasn't been a big issue. But for end user code, this is by far the easiest way to distribute code to people. If they have your realm file, your ZX realm file or your Zomp realm file, that tells them where to look for your primary node. It gives them the public key to everything, and you can have multiple realms simultaneously configured on an end user system, and they just click Vapor and then run stuff. And it's really nice. It's just, it doesn't look nice yet because I haven't really prioritized the bells and whistles. But anyway, this is the end of the Erltris, the Tetris in Erlang video series, and I'm going to wrap it up here. I might do one on Minesweeper, or I might do an animation game, like a dropping blocks thing, or dropping blocks. What I mean is like, the match 3 type thing, or color matching or something like that. Or I might do a Puyo Puyo game, like Dr. Mario type game, which my mom would love. My mom is actually, she was like featured Nintendo Power because she was like a literal master of Dr. Mario, which is just like she hates video games, but she's really good at that one. Anyway, I might do a Dr. Mario type Puyo Puyo game, or I might do some animation stuff or whatever. But if you got any ideas, if you're curious about anything, like can I do X in Erlang? Ask me a question in the comments, or send me an email, or catch me on IRC or Slack or Discord or whatever. And doing these videos is kind of fun, so I'd like to keep doing them. If you are working on the OTP team, please add audio-video library bindings in the same way that you've done WX, because it's really awesome that we can do this stuff. And using ZX, it's easy to get to end-user client systems, which is awesome. Now, and we've got the just-in-time compiler coming now. That's awesome. So we've got everything we need. We always write all these streaming servers and, esports servers and all these crazy network services are always written in Erlang. And then we can't write clients. Like I can't write a VoIP client in Erlang, but I can write the server. It's really weird. So I really think we should get the audio and video libraries bindings for Erlang working cross-platform, because it would just be absolutely awesome to be able to write both ends in Erlang and communicate just natively. To me, that makes a lot more sense than trying to put like JavaScript on the server side. Maybe I'm crazy, but that seems like more reasonable to me. So anyway, I'll stop rambling now. Thanks for sticking with me through this series. If you've watched from the beginning, you could check out, if you're curious about Erlang and this intrigues you, I've made a couple of other videos about things. They're not always the best scripted or structured discussions that I do, but there is a little bit of useful information here and there that I've put out in some other videos, so feel free to check those out. Like I said, if you got any ideas for videos that you'd like to see, or subjects you'd like to see me address, let me know, and I'll do it if I can get some time. So thanks for watching, guys.